It is so wonderful to have so many people here. We're going to go ahead and jump right in. Hi there. My name is Theresa Wills. I am an assistant professor at George Mason University in the Mathematics Education Leadership Department. I've been teaching online now for 10 years. This is my comfort zone. I recognize that many other people were kind of, just launched into this online learning and didn't necessarily have the time that I had in order to slowly learn the technology. But I'm here today to showcase to you how you can use this in your classrooms. Um, Regardless of how you teach, whether it is online or it is concurrent and more. Um, I'm going to go ahead and get started first just with some kind of get to know you stuff, and then I'll be posting in a Google link where you can have access to the slides as well. Let's get started. You'll notice I've got some contact information here on the beginning, and I also have a new book that just came out called Teaching Math at a Distance, where I share a lot of other tips for you all. But let's give you some really useful links as we get started here. The first one is where you can go to find templates. Since the pandemic started, I have worked to put all the templates of everything I've ever used up on the web. I've posted a link here in the chat box. And this is where you can go to get a variety of templates downloaded right to your computer, which you can use right away. A whole bunch of things. There are some that are math related. There are some that are just kind of everything related. So one less thing for you all to do. The other link I have on here, which I'm going to put in the chat box, is more examples of what we're going to do today. So today we're going to do a routine and a rich task. But if you're like, hey, I'd like something that's a little bit more second grade or a little more sixth grade or a little more 10th grade or more, I have 33 other rich tasks along with a math routine here for you. These are hour-long math blocks that you can check out at your own convenience. So that's that second link. And if you are curious to learn more about the program we do here at George Mason, I've got some information about being a math specialist, and I can already see we have several alum here today. So hi, everyone. It's been a little while since I've seen some of you. So let's get started in the math. Alrighty, I'm gonna get this going. I got a little video for us to watch. We're gonna start off with a little video.
What are you going to order?
I don't know. The fish looks good.
I don't like fish. I was fishing off the coast of Alaska when Dog jumped in the water and he was all wet. It reminded me of the song about a man whose dog dies and his truck stops working, and there was something about a train. Even though my dog didn't die and I don't have a truck because I was on a boat, but it made me really sad. So once I listened to it backwards to see if the truck would start working and the dog didn't die, but it just sounded weird and I was still sad. Do you ever listen to country music backwards?
What are you even talking about?
Fish! I'm talking about fish because it reminds me of when my dog died, like that movie that had that guy in it from the other movie that was hilarious, remember? It was about space and there was the woman with the blue hair. I laughed so hard milk came out of my nose.
Oh, my phone is ringing.
I don't hear a phone.
No, really, I have to take this. That entire time, I spoke 25 words to his 175. That means for every one word I spoke, he spoke 7 words. He spoke 7 times as much as I did. 7 times! It was like me, talk, him, talk, 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 talk. Me, talk, him, talk, 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 talk. So, do you like fish?
Don't like fish.
I asked the last guy I dated about fish, and he rambled on about trucks all night. Have you ever dated someone who talks too much?
Can't trust fish.
My phone is ringing. That entire time I spoke 36 words to his 6. For every 6 words I spoke, he only spoke 1 word. I spoke 6 times as much as he did. 6 times! It was like me. Talk, 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 talk. Him. Talk. All I want is a guy that can talk with me on a 1-to-1 ratio. So, do you like fish?
I don't like fish. My roommate does, though. Do you like fish?
I do like fish. Gosh, I've been on some bad dates lately.
Funny. My roommate says the same thing.
Do your dates talk about fish?
Not really. Do yours?
One date talked about fish, had a truck, and listened to country music backwards.
My roommate talks about fish, has a truck, and listens to country music backwards.
I think
you
I dated your roommate. Have you noticed we talk about the same amount? A 1-to-1 ratio.
Indeed, we do talk about the same amount. A 1-to-1 ratio. Bread.
All right, folks. So that is Math Snacks. It's a fabulous start into our lesson today. We're going to be talking about fractions, ratios, and proportions, and gosh, how we use those in our real world, whether we're going on a date where we talk to people about fish or we're just doing math. And so let's go ahead and start off with a math routine. Um, this next part is interactive, where you are actually going to write directly on the slides. We do have a large group with us tonight, but I think I've got a nice way for us to all interact on the slides. Um, you'll notice there's a link in the chat box. If you would like to paste things to the slide, you want to have your voice on it, you want to have even your pictures on it, you're welcome to click that link. That'll bring you right in. And our first routine is called Find It. One of the most beautiful things about teaching online is people have access to their homes or a place where they might be able to grab more things, touch more things, gather more things. And so this routine called Find It is all about you finding something that has an example of a 1-to-1 ratio or something really close to a 1-to-1 ratio. So get up, stretch your legs, look around. If you prefer to draw things on the computer, you can do that. But what we're interested in right now is that we get lots and lots and lots of examples of a 1-to-1 ratio. So you'll notice beginning on slide 7, there are lots of little boxes. These are for you to put in your own thinking. If you would like to type your name, you can. If you want to upload a picture, you can. If you're somebody who likes to use clip art, you can. If you're someone who wants to draw on your own notebook and just keep it to yourself, you can. But I'd love to see, what are you thinking about a 1-to-1 ratio? For me, I've got this little monster that my son made me, and I noticed that eyes, horns, wings, and feet have about a 1-to-1 ratio. So that's something that I might add. I see people are adding text and images. And by the way, if this style of interacting on Google Docs is new to you, don't worry at all. I've got several kind of little tutorials for you to watch and frequently asked questions and more. But this is a chance for us to see what other people have in terms of a 1-to-1 ratio. And I see pets, a 1-to-1 with a dog and a cat. Ah, and I'll invite a couple of you all to elaborate a little bit more. That way we can get some discussion over the microphone. Cheryl, I would love to invite you to turn on your mic if you'd like. On slide 8, you talk about your recipe. What are you thinking of baking, and why is this a 1-to-1 ratio?
So this is actually a recipe for a Swedish almond cake, and it includes 1 1/4 cups of flour and 1 1/4 cups of sugar. So equal parts.
Awesome. Equal parts, even though, um, so even though I said 1 to 1, you have up 1 1/4 to 1 1/4. And that's going to bring up some really interesting discussion. Mary, I'd love to hear from you. Can you elaborate a little bit about your tree? And if you do find your mic, feel free to go ahead and turn it on. If not, that is okay. Um, let's see, who's got this, the cute little picture of the 2 horses? I can definitely see some 1 to 1 there. And Debbie, you noticed something in your silverware drawer. Would you tell us a little bit more about that?
Sure. It, over the break, I actually rearranged some things in there and realized that I really do have the same number of teaspoons as I do salad forks. So that just went through my mind.
You know, Debbie, this is a very a great example of how our households are different. I think we have 27 knives and only 8 spoons. I don't know where all our spoons went, but we do not have that 1 to 1 ratio. So glad you
Well,
you shared that.
it's not the same on the other pieces, just those two.
And you know, Debbie, I couldn't have come up with a better beginning example for what we're going to do today because we're actually going to talk about things that might not have a 1 to 1 ratio in our task. But this is fabulous.
Hi.
All right, folks. So as you can see, some people are using clip art. Some people are just writing what they know about, what they have. But what's really cool, if you haven't experienced it yet, on slide 6, there's a little image there, an animation that shows you how to take a picture of your own notebook, or oftentimes with my students, their own uh, their own creation that they made. Thank you, Abby. And so if you want to add your own images, you can do that. But what I like about this routine is that it involves all of my students. It's not just the kid who's the loudest. It's not just the kid who's quick to raise their hand. Every single one of my students has the opportunity to have a voice and a space on these slides. All right, you all came here for some rich math tasks. We're going to jump right into them. If you want to take a peek at slide 15, it's also what I'm sharing on the main screen. Why do we do rich tasks? What's the point of it? I like to ground what we do in research, and according to the National Council of Teachers of Mathematics, these are the 8 math teaching practices. What you'll see tonight in the rich task uses all 8 of these, not just 1 or 2, all 8, and they're right out in front and center. But before we begin, let's see who is ready, who's got their math hats on and ready to go. I have a lovely problem-solving oath on slide 16, and I use this every time I do a task. As I read it out loud, see if this is something that you would like to do, and if you do, type your name in the chat box. That's how you can show this oath. I, Theresa, promise to try my best. I will make sense of patterns and numbers. I will use manipulatives and drawings. I will make mistakes. I will ask questions. I will listen to other ideas. I will stay engaged by always trying to find another solution or representation. I am a problem solver. I make the world a better place. Look at all these problem solvers we have here. And this is just such a great way to start off our math task. Much like Debbie alluded earlier, our task is about things that you might have in your kitchen. Slide 17 has a little graphic. I don't know if this is the case with any of you all. This is the case of me. 27 knives and 8 spoons. And when it comes to Tupperware, boy, I have some trouble with some Tupperware. I pull one out and they all come out. I don't know if you all have this situation. This is definitely me. So this brings us to our task. On slide 18, our task says, Grandma has a lot of Tupperware. Sometimes a container or lid becomes cracked and she throws it away. But she usually forgets to throw away the matching lid or container. This means that her already unorganized Tupperware cabinet has several pieces that don't even match. After taking an inventory, we found out that 2/3 of the lids match with a container, and 3/5 of the containers match with a lid. We want to know what portion of Grandma's Tupperware matches. For tonight's tasks, I have arranged 5 virtual manipulatives that I think would be really good to use in this. You're not restricted to them. Use whatever you want. But those manipulatives can be found on slide 19. They're clickable. You can go in, you can click them, play around with some stuff. And in just a minute, I'm going to put you in breakout groups. You're going to work for a good 20 minutes with a small group. And you're going to try and get as many representations on your screen as you can that shows this problem. Welcome back, welcome back, welcome back, everyone. We are now back together in the main room. What a wonderful job you all did, not only talking to one another, making new friends, but also showing some different representations. So take a quick moment and look at these 10 slides. You all had 20 minutes to work, and you came up with this many representations. Let's just take a minute and really soak in all these different ways of seeing it. And I know that several groups were right on that verge of like, oh, we got it. And so now we're going to unpack the mathematics here and talk about why this problem is so tough for so many students and even adults to fully grapple. So let's dive into the fun parts of this. If you head down to slide 30, I'm also going to share my screen from here on out so you can follow along that way if you prefer. When I do whole group conversations, I always follow the 5 practices as stated by Smith and Stein, and that's where ahead of time I have anticipated a lot of different ways of solving this problem. I have monitored by going into your breakout rooms. You probably heard me step in and say, hi everyone, how's it going? Ask you all some probing questions and more. I've selected a couple to look at, which we're going to do in a moment here. And I've sequenced them very purposefully to try and draw out misconceptions at the same time as bringing the mathematics to the center. And then we're going to finish off by making some connections. So without further ado, come on down to slide 31, or you can just watch on Collaborate, either one. And group 6 was getting started with something here. I love the simplistic nature of this. If you were the one who made these triangles and circles, would you mind turning on your mic and just sharing with us what were you starting to develop here? What is this representation? So if you were the person or maybe even just the group that came up with that, I'd love to see what it is that you were thinking about. And I see someone's typing in there. So I'm curious if anyone else sees a connection with triangles and lids. Go ahead in the chat box and put an emoji. Like, do you see this connection right away? Are you thinking, gosh, I'm a little confused. I don't know what these triangles or circles are. Um, Give me an emoji with how you're feeling right now with this. Cool. So just a quick check-in. I see a couple of people are like, hey, I'm good. All righty. And the nature of the problem was all about matching the lids, but currently they don't match up. Like if I put a little triangle on top of a circle, I got extras. So I need to figure out what to do to really solve this problem. And I noticed that there are several thumbs up, so I'm going to use that to just kind of figure out who should speak next. Natalie, I noticed you said I can see it. Um, Tell us how you see it and what you think I should do to make matches.
So um, I would continue to add triangles in the same ratio.
So I can't
So
just add
two
like an extra triangle
blue,
because I feel like it?
yep. And then um, add, so now that they still don't match, so I would have to add another set of the 3 circles and the 2 circles, and I would keep going until they equaled each other.
All right, so you're going to keep going till they equal each other. So like we've tried to match them here, and now we're left with like not the situation we want necessarily. And Natalie, can I just like add extra yellow circles like this?
No, because you have to keep the ratio consistent, so you have to use 2 grays as well.
Those gray ones, those are the like obnoxious ones that don't match up, right? All right, so now I've got some more circles. Are they all matched up? Gosh, what would I do next? Um, and so, I can start to bring these little triangles down and try to make matches, but it's still not happening. I'm going to give you all some of the freedom of the slides here. If you see a way that these can match up, go ahead and raise a hand. I'm going to call on you. You get to take control of the mic. You get to tell us like what to do. How do I make these matches? How am I possibly going to be doing this? And I do see one hand up. The name up is showing M, so I'd love to know who you are if you'd like to share. And like, how do I match these? Like, this is a conundrum.
If you did the blue triangle set with one triangle, gray triangle one more time, you would have enough lids for those last 2 containers, those last 2 yellow containers.
Exactly. There we go. We've got it. We've got lids that match containers. But then our next big question is, what does that mean in terms of the problem? And in this problem, a lot of people started off with this idea of common denominators, because that's frequently what we would do in a math class. We would, start with common denominators and then do something with it. And so I'd like us to look at something that might be a little more familiar to us teachers. And that's down on slide 34. Come on down there. Let's take a peek at these 2 representations. Slide 34. And I'd love to invite, I know there are 2 different people who did these. If you were one of the 2 models that are represented here, if you wouldn't mind turning on your microphone and just sharing with us what you're thinking, what's happening here. let's see, someone was in group 10 and the other one was one of the different groups. And that's all right if they had already logged off or didn't want to bring it up. Oh, Megan, go ahead.
Whoops. Can you hear me?
I sure can.
Oh, okay. So I was thinking that there's going to be some overlap between the lids and the containers and then the containers to the lids. So there's going to be some overlap between the two fractions. So first I did 3/5 of the whole 15 as orange and then 2/5 of the whole 15 as blue, and whatever was in common, I shaded those pink. So the 6 pink pieces are kind of like the overlap or crosshair between the two fractions.
Neat. So you have 3/5 kind of there and your other 2/5 over here.
Mm-hmm.
And then tell me about how did you know to make 3 rows? Why not like 27 rows? Why not just 1 row? Why are there 3?
You mean 3 horizontally going across?
Yeah.
I think I was doing what most people were doing, which was thinking of like the least common denominator. Like, well, if I have 15 Tupperwares and 15 lids, here's how it would look nice and neatly, with colors.
Yeah. So let's kind of break apart what this is and bring it together with our other model. Our other model, when we started off with, when we talked about triangles and circles, our other model looked like that.
She has, the pink and the blue look like, okay, so the pink looks like our yellow circles and blue triangles, and then the blue looks like those empty circles.
Yes. All right. So we're seeing some connections here with those. And I'm going to give everyone else a minute. We're at this brink of possibly like, I got it. I think I've got the hang of this.
Then her,
So what I'd like everyone to do in the
the,
chat box, this is everyone's chance to have a voice. What does the blue, I'm going to delete the other one out. What does the blue section mean in terms of our circles and triangles? And what does the orange section mean in terms of our circles and triangles? In the chat box, try to make some sense of that. If we were to match it up, where would it be? What would it look like? Mm-hmm. Lisa, if it's all right, I'd love to call on you to turn on your microphone and just kind of share with us. You mentioned that the blue, what did you say? Blue containers are without a match. How do you see it in the triangles and circles?
I see 4 blue squares that didn't match up with anything, and I have 4 circles down here that represented containers. And then up here I see 3 orange squares that didn't match up with anything, like they weren't part of that overlap. And I have 3 triangles or lids that didn't match up.
Awesome. So we have our oranges there. So, folks, this is actually a really interesting problem because so often we teach students to make common denominators, or maybe that was our first way of going towards it. But then the big question is, why do we go towards common denominators? And why might we want a numerator to match a denominator? And when in mathematics does this happen? One of the things that I like to bring out in mathematics is the problem solving approach to things and the way that we can use different manipulatives to showcase the different ways that we can see numbers here. I had some major questions that I was hoping to get to tonight, and I think we did these. Those questions are on slide 35. They have guided me in my thinking about who to select to talk, which representations do we pick, and which ones do I want to connect. And so those were kind of my guiding questions. As we round out the end of the hour here, what I hope to showcase to you all is a way that you might choose to do a math block if you had a 1 hour math block available. We started off with a funny video. I thought it was funny. We went into a rich task, or we went into a routine and then into a rich task. You had some virtual manipulatives. And while many of us had learned new things with the technology, it may have been, how do you do a screenshot? Or it may have been, why do we find common denominators? You all had a useful way of bringing your expertise to the group. So this was an absolute pleasure. I hope that you got a new task you can use with your students to uncover what fractions really mean and what ratios really mean and why you would double your ratios or triple your ratios, and how this relates to problem solving. As we end here, I wanted to stay on for anyone who has any questions. You're welcome to type them in the virtual parking lot if you choose. You're also willing to ask them here. And if you would like more information on the Math Specialist program, this is the program that I teach in at Mason. I'm going to go ahead and put that on slide 36. What's the answer? That's often a question that we get here. So the question was, what portion of Grandma's Tupperware were matches? And we have 6 pieces that matched another 6 pieces. So we have 12 pieces that match out of the 19 pieces all together. So I'm going to go ahead and put a little arrow over there that shows that. Well, folks, it's been a pleasure. I'm happy to take questions. Like I said, I'm very comfortable teaching online. This is my favorite thing to do. If you want to learn more about it, definitely check out. You can also email me. You can visit my website if you're interested in more templates. But I hope that you saw a way of doing math routines and a rich task in a way that's interactive and gives students a voice. Somebody mentioned, how are you organized and fast? Well, I'll show you a little bit of a method to the madness. First thing I did was anticipate these problems. I anticipated lots of different ways that you could have possibly gotten this answer. And then I started looking for them. So as you all are adding representations to your slide, I'm looking around at the slides, trying to find these different representations. And when I find them, I copy and paste them on the slides below, because those are going to be like our talk about slides. I recommend, I mean, obviously doing this with 85 people, there was a lot more up there, but in a regular class size, it's pretty easy to be able to go into the breakout rooms and just listen to what's going on. And as I'm listening to group 1, I'm also looking at groups 2, 3, 4, and 5 on their slide, and the representations that they're bringing in. I'm kind of stealing from there. So that's a little bit of the method to my madness. Linda wanted a copy of the slides. Here's how you do it. You go to File, Make a Copy, Entire Presentation, and now it's yours. It's in your Google Drive, and you have permanent access to it.
Thank you.
Yeah, sure thing.
I'm like one of the other ladies. I have been out of teaching for quite a long time, and this is my first year back, which is exciting, but I'm having to learn a lot right away as far as the slides and things. So thank you.
Yeah, and I do recognize that, it's a very different world that I was in when I started 10 years ago, and I started very small and like little baby steps. And most of the world has been just flung into this online learning. Some things that I'd recommend is just take one idea that you like at a time and implement that one idea. And, as you get students who are better and better at the technology, keep a record of it. This is an example of one of my records. Let me see. Let me turn down my light so you can see it.
Well, I work with the special ed children in math, and
Uh-huh.
and we've been using quite a few visuals where they seem to understand it better, which I like a lot.
Yeah, and you know what I find, and this is even for really young kiddos. I know that this problem that we talked about is more of like the third through seventh grade, anywhere in that range. But even young kids. So I have a group of Girl Scouts that I work with that are kindergartners and first graders, and it's amazing to see how quickly they've learned to do screenshots and paste those on. And we just get silly with making mistakes and having fun with it so that we can get more used to it. And I've learned that kids are really, really flexible right now, and it's a great chance for us to kind of show productive struggle with how we're doing it.
Well, they do much better than I do. They can present their screens back to me, what they're doing, and so I'm learning,
Yeah.
attending many classes so I can catch up. But math is what I teach, and I want them to be able to understand what we're talking about. And this was really interesting. Thank you.
Yeah, sure thing. Let's see,
I did
Danielle.
make a copy.
Oh, what was that?
I said I did make a copy of your slides. Thank
Oh,
you.
perfect. Yeah, glad you have that. Danielle, you mentioned what does rich task mean? And there are several definitions, but here's some important things with a rich task, that it can be solved so many different ways. As you're solving it, you might try one strategy, you might move over to something else, but it's that you can approach it. You can start to solve it one way. It's open and accessible to a lot of different learners. And a really important part is that students can work on it for about 20 minutes, coming up with different representations. And then you can go in there and share those representations in the whole class discussion.
What's some of the tips for helping students and teachers use the online Cuisinart rod manipulative?
Yeah, sure. So the nice thing about Cuisinart rods is it's some of the same things that you've probably seen in the classroom. Um, and
Right.
that's that, they can stay that size. But if I was trying to, work this problem and I'm trying to show 3/5 again and again, I can grab a 3 and a 2, a 3 and a 2. And so I can keep showing this ratio doubling and then tripling, but maintaining the same ratio. And that's really useful as opposed to drawing something out and then trying to count every single one of them that you drew out. Sometimes the visual of the virtual one is easier for kiddos. Um, Let me think. Yeah, I find that they use them for ways that I wouldn't have necessarily interpreted. That I would have expected them to use it for one thing and then they use it for something completely different. But just being able to make these sizes that don't ever change can be useful in fractions and ratios.
It looks like it doesn't go all the way up. I couldn't get it, like if I wanted to play with it to go to a common denominator 15, it won't do it. It's only going to 10 like the actual hand hand rods work, correct?
Yep. And so sometimes I'll see students do things like a 10 and a 5, and then like now they have their 15 up there. And then what was the other one?
Right.
2/3. Oh, that's supposed to put that there. So that's kind of how I would have imagined that they would use this. The other important thing is when you're giving them virtual manipulatives, I try to always give them one that they're very comfortable with, one that's brand new if I can, and one that's something that's super techy, because I find that the different types of kids that will gravitate towards them bring more representations to our class session. So as you notice here, the interactive hundreds chart was one that I thought would be pretty easy for people to start to play with. And then they kind of gradually grow in complexity. And I do that so that they can have some choice in what they choose.
Question, when I first started with these manipulatives, when they were hand,
Uh-huh.
they weren't virtual, they suggested that you let the children, the students explore with them to see how they could react. Do you do that with the virtual ones as well
Absolutely.
before you just present it?
So when I'm online, I do it in a way that I want to see what they know with the technology. And so I'll say, hey, everyone,
Okay.
go in and make something silly with the hundreds chart and then do a screen capture and show it to me on Google Slides. Now, I realize that every kid can make a funny picture using the hundreds chart. I'm not actually assessing that. They're having fun with it. What I'm doing during that time is I'm working with kids to make sure that they can upload it onto the slides. So that gives me the chance to give that like one-on-one attention when I need to. And everyone else is busy doing that exploratory part that is so essential in using virtual manipulatives.
Okay. All right. Thank you.
All right, folks. Well, it's been a pleasure. I'm happy to continue to connect with you all. I've got my contact information there on the top slide, but it's been a pleasure, and I hope that you had some fun with math tonight.